Manager. And then from the Pixit side, we have Andrew Wierzan, and he's the VP Product Evangelist. So I'd like to get started on our webinar. If anyone has any questions or concerns as we move along, please feel free to type them in and we'll answer them when we can. At the end of our session, we'll also have a question and answer period. And we do welcome your questions and we'll answer them as best we can. This webinar session is also being recorded and we will be happy to send it out to you later today. So without further ado, Tom, I'll let you take over. Thank you.
Thanks, Michelle. I'm Tom Johnson. I'm the product manager in charge of Ethernet for ATTO Technology, and I control the development of our FastFrame SmartNICs and our new software ATTO 360. The purpose of this webinar today was to showcase one of our greatest partners, Pixit Media. My colleague Andrew had sent me a white paper, a case study that they had done, and he's going to talk about several case studies today, actually. But the one that caught my eye was NVMe over fabrics, and I thought it timed right with a new release that we had. FastFrame is our SmartNIC adapter line. We are in our 3rd generation now. We go up to 100 gigs. ATTO is known for having the best hardware, the best performance, and the lowest latency. We've been making storage adapters for over 30 years now. And a lot of the themes that you'll hear about today is Ethernet and how Ethernet as a protocol can handle any type of production workflow now. Especially with these modern protocols like RDMA and NVMe over fabrics. And one of the things ATTO is known for is making everything simple. You know, we tend to have customers that are very creative, but they're not as savvy technically. And we try and let our customers lean on our experience. And one of the things that we offer is a free download to manage our adapters. So when you're connecting via your clients up to storage, there are one of the recurring themes that we heard in the Ethernet world is how hard it is to manage. The performance expectations aren't reality, and we can get performance up on Ethernet by doing a few things. One of them is tuning. So our ATTO 360 is, like I said, is a free application that it's really an all-purpose tool, but it covers 3 areas: tuning, analytics, and monitoring. On the tuning side, we have one-click setup. So we've set up these tuning profiles. We try and match them to workflows. If you're looking for the highest throughput, if you're connecting via older TCP methods like NFS or SMB, we have these optimization profiles. And the latest one that we just added in our version 3 is RDMA profiles. So we have NVMe over fabrics. We have ICER and NFS over RDMA. But the idea is to give the user a simple way to optimize. So it's really one-click button in the background. We're doing several things. Could be as many as 70 different configurations that are making, and we're using common utilities, but we've tested and validated and found the right settings to be able to get the most out of your client and its connection to storage. Analytics and monitoring side, we've gone through and in the problems that we've faced in the past and the bottlenecks that we faced in the past, we've tried our best to make sure that our customers don't fall into any of those pitfalls. And so we're constantly, whether in real time or via a time series database, monitoring thousands of metrics, and we've set thresholds to know when certain things are happening. You know, we know that you're always dropping packets with Ethernet, but we know the right number of packets to know that there might be something going on. There are small things like you're using the wrong driver or you're plugged in the wrong PCI slot, to very complicated things. We're looking at 6 different buffers and constantly monitoring to see if there's any type of error that's happening, and giving you instant advice to see if we could fix those bottlenecks. And the benefit really, whether you're an end user or a reseller, is really about saving time, getting you back to work on your projects faster. Leaning on ATTO and our experience and how to optimize your client's connection, and not having to mess around or configure. You can just get right to work, and troubleshooting is a breeze. You can do that with great accuracy using the tools that are in ATTO 360. And the latest version, as I said, we introduced RDMA support. So there's a custom installer now that sets up all of the dependencies that you need to run NVMe fabrics or any type of RDMA protocol, and we make it a breeze. Again, it's a free application. Feel free to download it on our website. Reach out to us if you'd like a demo. But I'm going to hand it over to Andrew because, like I said, I saw his white paper and I was very interested in it, and I wanted to highlight what Pixit Media is doing for several different use cases and production workflows. So take it away, Andrew.
Thanks, Tom. Yeah, so my name is Andrew Wierzan. I look after products, and I have the great job of evangelizing about them over at Pixit Media. So today I'm very briefly going to just explain who we are at Pixit Media, and then through telling a few of our customer stories, I'm gonna start to challenge the sort of the assumption that SAN and Fibre Channel is still necessary across many aspects of media and entertainment, not just the sort of the straight line speed that it's been associated with. So first, a little bit about Pixit Media. So we're an award-winning software-defined storage solutions company. We were born out of the media and entertainment industry, and that's where our strength lies. And we provide complete solutions to many of the world's major content owners, film studios, broadcasters, production and visual effects houses. So we're born out of media, and this is very much our comfort zone. And we're familiar with not only the challenges of technically delivering for the media and entertainment industry, but also what our customers and our customers' challenges are. So we obsess about our customers because media is cool. So what am I going to talk to you about? It's really this preconception that, do you need a SAN anymore? So SANs have been firmly kind of knocked off the pedestal with the advent of Ethernet and those storage appliances that were able to deliver performance, perhaps through things like caching. So they deliver a SAN-like experience, but there's still a go-to, a comfort zone, particularly for leadership and for technology decision makers to go, well, hold on a second, I've got a real-time workload that is of a certain weight, and it has a certain bandwidth requirement. And so a lot of people are still going to SAN and almost sort of not looking at the advances that ourselves and the likes of ATTO have made to really implement Ethernet in a way that is relevant to the industry. Because SANs, it still has a place. They're still trusted to deliver those real-time frames, particularly when the frames are getting bigger. When we go into 4K, HDR, 8K, and the higher end deliverables, that's a lot of data to shift. And that's where sort of going down the commodity IT route and the appliance storage approach, there isn't the bandwidth available. So we need to just reframe the problem. So the first story I'm going to share with you, we're shooting a film. We're either on location or we're on a film lot somewhere. If we ignore storage for a second, if we think about the file flows, everything that's coming into this central pool of data, and then potentially going out and being processed, the job to be done is to take raw camera footage, get it into the pipeline, get it protected, because these are sort of film shots that maybe can't be recreated. So we need to protect our data. We need to process it so that it's useful further on down the line into the post-production and the visual effects process. And then we need to get it out, because we can't hinder any of the creative process. So if we now think about that in terms of the actual file flows, so now we'll flip over to the next slide. I'm going to start at the left-hand side of the diagram. So we've got, if we just, yeah, that's it. So if we just look at our raw camera footage, so that will possibly be coming directly off the camera, that will be going from camera cards. But this is raw files effectively. So they're being wrangled into storage by dailies ingest technicians. They're logging, they're doing metadata into the production. So that's heavy on the writes. So we're writing data into this central pool of storage. And then if we look at the first thing to do, we're going to protect it. So we're going to take a copy. Traditionally, we might have written it out to LTO. We might be going out to cloud. So now we're writing in because we're camera ingesting, and then we're writing that, and then we're reading a lot of data out to those LTOs. And now then the heavyweight component, which is where we're going to start to drill down, is we have to process that media. And we're using the example of ColorFront's transcoder here. So what that's going to do, that's going to read those raw camera frames, and it's going to convert them into something more useful to the workflow. So EXRs, DPXs, perhaps apply some pre-grades so that we can review them. And so that's heavy on the reads, heavy on the writes. And then in the top right-hand corner of this diagram, we've got our production staff, so producers, directors, DOPs. What they're doing is they need to have the confidence that those frames are good. They're good to be shipped to the next step. So this is the portion of the onset system that will be having to deliver real time into the director, because the director can't suffer drop frames or can't wait for an application to buffer. They've got their own job to do. So this is where, particularly for that real time element, you may implement a SAM. So now if we express that in terms, we've looked at the file flow. If we express that in terms of raw numbers, what I've just described to you, based on something like a Sony camera shooting 225 megabytes a second, if we had 4 camera cards being ingested, maybe a couple of review stations, and archiving to LTO, we're looking at an overall aggregate data rate of in the region of 7 to 8 gigabytes per second. That's big B across the storage. But then we also have to make sure that those real-time review stations, they are guaranteed their bandwidth. So we can't compromise. And this is very much where the PicStore solution comes into play, because within PicStore's design, it's possible for us to carve off or dedicate bandwidth to these real-time workloads and then to these non-real-time workloads. So that's PicStore in a nutshell in context to onset. Now I'm going to focus on that transcoder piece initially. So really, you can see the charts in front of you, but here at Pixit Media in the UK, we've got a lab, and we perform benchmarks on our own stuff and other people's software. And so what we did, we took a PicStore solution with a singular sort of standard config, and that's reflected across all of the benchmarks that we're going to be discussing today. And then we took a transcoder system, which was kindly supplied to us by ColorFront. Now this is a HP Z8 series crate with multiple GPUs in, and it's a drag racer. A lot of people will be using them with inbuilt SSDs just to be able to feed those GPUs. And then the go-to position might be, well, hold on a second, I should attach it to a SAM so that at least it's in the shared storage environment. But what we've been able to demonstrate through 2 benchmarks, which is what these graphs reflect, is that through the PicStore solution, using NVMe over Fabrics, we're able to deliver greater than SAN speed, bearing in mind that the dollars per gigabyte per second metric is far more cost effective than, say, trying to implement an entirely new fiber channel network at 32 gigabits. So the top graph is that's the straight line test. That's a benchmark called the benchmark pipeline. What Transcoder does, it tries to read from the storage as fast as it possibly can. So it's kind of a bit artificial, but that gives us a real straight line speed. And then the bottom chart is the Transcoder real world test. So that's where we took some camera raw, we threw it through the GPUs, and then we wrote out some EXR frames, some DPX frames. And as you can see, the scaling is slightly different, because in the real world test, we thought it was fair to, rather than benchmark ourselves against 32 gig fiber, we put it into perspective. How many film productions have existing or incumbent 8 and 16 gigabit fiber channel networks? And so this is where we compared. So I think, in short, thanks to the incredible progression that ATTO have made in their Ethernet NICs and the underlying PICstore solution, we're able to deliver some fantastic speeds, which will only get better as those Ethernet sort of speeds and protocols get adopted. So what I'm going to do, I'm going to pause for breath, but really, if we think about that onset story, and now if we start to follow those files through to our next slide, well, where are they going to end up? And this comes into story number 2, which again, at Pixit Media, we've got a lot of customers that carry out this sort of work. So if we're talking about a high-end production facility, they may not just be working with one customer on one project, on one film, one campaign. It's likely they're going to be running multiple projects for multiple customers and different sort of lengths of timeline and pipeline. So effectively, the challenge here is to feed all of the creativity that's taking place in their 4 walls, so to speak, and all of the sort of the creative services. Now, a common trait and an interesting observation is that these types of facilities tend to encounter a couple of challenges. First of all, storage tends to reside in islands. So if we hop over to the next slide, if we think about the file flow through one of these facilities, there might be some storage sat in a DMZ. So incoming deliveries are quarantined as per things like MPAA guidelines and TPN accreditations. And then the administrative staff might be using some general file storage to handle scripts and artwork and things like that. And then there'll be, your kind of lighter data rate stuff like editing, graphics, that sort of thing. And there might be an allocation of nearline storage, and then you have the high-end stuff. So your color grading suites, your mastering, your flames, your resolves, that sort of thing. So the 2 challenges that this type of facility might encounter is that there's storage islands everywhere. So there's data constantly having to be wrangled left to right in this diagram. Now that is inherently inefficient, and it results in duplication. Even if there's a bit of automation, you tend to get duplication between these places. And then the other challenge is that the technology teams that are responsible for these, you could literally hang a different storage vendor's badge off each of these buckets of storage. So the technology teams and the decision makers have to become generalists. Now that's a challenge in itself, because you end up with a broad knowledge as opposed to a depth of knowledge in one particular technology. So if we go to the sort of the next slide, the way we are able to do it here at Pixit Media is the PICstore again can represent this kind of central logical pool of storage, where on the bottom half of the diagram, we can wrap around many different technologies. So we can wrap around cloud, nearline, NVMe over fabrics, all of the disk classes, and segregate it in a way that is Studios compliant, so we can still serve the likes of those DMZ workflows. But on the top half of the diagram, as far as users are concerned, is they just see some shares. So this whole act of data wrangling becomes much more easier to conceptualize and to actually carry out day to day. So files can flow much more easily. So kind of having one throat to choke on the solution is a nice thing. But then if we look to the other aspect, is when you're making a decision as to, well, how do I validate that this solution is fit for purpose? Well, then a lot of people, technology, decision makers, that sort of thing, will often lean on benchmarking software that has historically been used to validate SANs. The most common one is an application called Frame Test. And so if you're a generalist and you're trying to make a decision as to, okay, I'm going to buy some storage to service my needs, well, how do I get comfort? Let's strip back the marketing. Let's actually sort of validate this myself. So I'm going to get a test system and I'm going to run Frame Test, because Frame Test is right. It works on my SAN, so it's going to work on my NAS or my global namespace. So what we demonstrated in the Pixit Media Lab is that we took a whole array of benchmark applications and we tested them. On the left-hand side of the diagram, we tested them on exactly the same underlying storage. So we're talking a PIC-Store solution that stayed the same, a back-end network and a front-end production network that stayed exactly the same, all based on Ethernet, and then ATTO interface cards out to the workstations. The workstations again were the same. And as you can see, we got some pretty significant dips and variances in performance over those NAS protocols. But then what we also did, we compared Frame Test, because it's probably the most widely used of these benchmarking applications. We compared that against what we were able to achieve in context to a PIC-Store solution. So the sort of thing that we would deliver our customers. So a PIC-Store solution feeding Blackmagic Resolve. And as you can see, those red lines and blue lines, there's variance. Sometimes it's quite stark. And for me, the most interesting thing is that depending on the context, it's actually possible to exceed what the benchmark tool thought you would get. So really the message here is that the benchmarking process is perhaps in need of being updated. And also tools like ATTO 360 are really us moving into a world where we don't just think about the speed that's coming off your drive spindles, so to speak, in a drive array, but we actually think about that full suite from the blocks on disk all the way through your Ethernet network, up to your workstation, out to the application, and to those eyes that are looking at the glass, sort of metaphorically speaking. So if we now move on to our third story, well, that would be based around another chunk of the Pixit customers that we have, which is post-production. So I've described onset and I've described high-end facilities, but there's a lot of people working with compressed videos where perhaps their end-to-end doesn't use full kind of 10-bit, 16-bit frames, but they're actually shooting directly to those compressed video formats. Now, this could be a post-production shop, it could be a creative agency, it could be many different types of businesses within our industry. And the challenge here is that they might have historically bought SANs because the equivalent commodity IT appliance was not fit for purpose, but actually the reason they were buying a SAN is because they just wanted the confidence that those frames would play back every time. So if we hop over to the next slide, we can start to see that the file flow is agonizingly similar to what we saw on set. So we have footage on location, we might bring it into a central location, and then we might use common tool sets like Adobe Creative Cloud, Avid, Resolve. All the while we're handling compressed video codecs. And that's the key here, is with that video compression, rather than sort of requiring raw data rate from my storage through to my application, actually what we've done is the payoff is we squashed those files so they were more efficient on storage. So we could move them around, they didn't take as much space up, but the cost to that compression is that the workstation and the application have to work harder because they have to decompress it, get it into their playback buffers, and then get it out to the eyes that are editing. So there's two things, and Tom actually touched on this, that the reason SAN gives a sense of this being more efficient is because the journey in that workstation to application is fundamentally different to with the NAS protocols. It doesn't have to travel through things like the operating system's TCP stack, and there's different kind of compute dedicated to it. So benefits in workstation and application technology improve the experience. But what we did in the lab, again, with exactly the same setup that we've seen in the last two examples, we tried to express this in terms of, well, if I'm trying to decide what's good enough for my creative post-production shop, how would I compare real world against benchmarks? And so the results are quite notable. So the blue lines here are what a synthetic test tool, so something like Frame Test again, would give us. So that would tell me, hey, you've got a good amount of data rate, you're good to go. But with these highly compressed codecs, the red bars tell me actually, with exactly the same workstation, a HP Z800 attached using an ATTO network interface, those codecs are so compressed, they're pushing my CPU to the limit before my network got to the limit. And so you can see that it's possible to over provision parts of the overall design. And this is why we find a lot of post-production facilities maybe have a SAN that they're not necessarily utilizing to its full potential, because the workstations are handling codecs which just require more effort. To avoid over provisioning, we at Pixit Media, we take notice again beyond the storage. We go right up into the network, the application, and out to the users. So I think hopefully the three stories that I've shared are useful and helpful. All of the sort of the deeper information and all of the backstory behind what we've been discussing is in the three white papers that are available for download. But really, the key takeaways that I would love everyone around this table, so to speak, to be able to walk away with, is that NVMe over Fabric fundamentally provides a cost-effective alternative to SAN, but also a tangible real-world boost. So we can exceed what SAN and Fibre Channel are capable of, and it's massively more cost-efficient. That benchmarking software, so artificial benchmarking software, doesn't necessarily validate the entire environment, and so with the right solution we can outperform. But really, we at Pixit Media want to present ourselves as a partner who can help you actually answer the question, well, what does the holistic solution look like? Just because solution performance is influenced by many factors, from the storage through to the network, the workstation, the codec that's being used, so whether it's ProRes or DNxHR, and the application itself. So that's me, and thank you for hearing my stories.
Excellent. Thank you very much, Andrew, and thank you to Tom. So at this point, I'd like to take just a couple of seconds. If anyone has any questions, feel free to type them in the chat box, and then we'll go ahead and we'll read them. And again, we did record this, so it will be made available to you, so you can replay it again in the future. So I'll just take a couple of minutes here and see if we have any questions before we close for the day. I actually do see one that came up already, so I think I'll just start with this one. It says, what, for Tom and Andrew, it has both ATTO and Pixit in it, so either one of you, what are ATTO and Pixit doing to manage storage latency?
I can start. Great question. So I think ATTO 360 was a good example of the tuning that we're able to do on the client side. We can control through our driver settings in our driver and the client operating system. There are several things that we're doing, whether you're setting up on the if you're going via old school NFS or SMB type file sharing protocols. There are several things that ATTO 360 does automatically in the background. They're using syscontrol and other utilities, and as well as offloads in our driver, things like LRO and TSO are things that modern Ethernet NIC controllers are able to do to help alleviate what's going on with the CPU, and more modern, like NVMe over fabrics and RDMA. You know, like as Andrew said, getting the TCP stack out of the way really manages a lot of the latency, and you know, as you saw today, some of the numbers that Andrew was able to get are in part due to the things that, you know, we're able to do on the client side.
Cool. Yeah, and yeah, so just to express that from our side, I think so look, latency sort of depends on where in the stack you're hitting. So if we take the NVMe, the fabrics, the RDMA route into Pixtor as a shared storage environment, then yeah, we can absolutely crush those latencies. So as low as they can possibly go, and as ATTO improve things, they get lower. I think that one thing just to be sort of mindful of is that inherently, when we go down the TCP road into the system, that there's inherent latency in those NAS protocols, and so this is where even though some of the more IT appliance vendors might say, hey, look, we've got local caching, and so we can destroy latency, you'll never have another problem. Ultimately, you're still going through a NAS stack, so you're pushing your data through CPU cycles and a TCP stack on the storage on the server side, and then also you're kind of unpacking it on the workstation side. So yeah, we can get latency as low as it needs to be, and then right for the job in hand, if that's a fair question.
Excellent. That was a good question. There's a lot of questions here, actually. If I could back up. Let me read this one here. Has NVMe over network been tested in the multiple operating systems such as Mac, Linux, and Windows?
I think we're talking about Mac here, really, and there is no our NVMe over fabrics or RDMA support for the Mac OS world right now, but it is in Windows and Linux right now, and you can take advantage of it right now. You know, we are working with Apple. I can't tell you if they're, you know, a date that they would introduce support for that, but it could be something that the Mac community can take advantage of in a year or two. Would be my answer.
Certainly. And then maybe just to tag on to that, because yeah, this is a very commonly asked question. So so you'll notice in some of the benchmark results, we actually had we have some Mac workstations in the Pixit Media Lab. So we actually use the ATTO Thunderlink interface. So we have benchmarks from connecting at 10 gig and 25 gig. Now that is over the SMB protocols, but thankfully most of those Mac workloads tend to involve compressed videos or maybe some of that camera raw footage. So we can get some pretty impressive performance numbers out of the SMB stack on a Mac with a Pixtor solution, without having to kind of play the whole we need Apple to go fix some stuff cards. So yeah, if we think about the job to be done, maybe it's dailies ingest, maybe it's some post-production running some 4K codecs, like Mac is very much the tool for the job, and using like the Thunderlink adapters, they're awesome, quite frankly. So yeah, and we can demonstrate that in our lab.
Okay. Another question real quick. How does the ATTO and Pixit Media, how do you work with a Mac for onset?
So probably the most common deployment would be you're using something like that Thunderlink network interface card. that would then connect using 10 or 25 gig over like an SFP plus or something into a Pixit storage server. And then that would be able to access those shares using applications like ColorFront, their onset tool, or something like SilverStack, I think it is. It's possible to ingest that camera raw footage into there. And then obviously there's a lot of Mac applications that are associated with archiving from that onset pool back out to LTO. So we've got customers using LTO archive software for onset, again, reading from Pixstore back out to those LTOs.
All right. Are there any special software that's needed to join a Windows workstation into a GPFS Pixit cluster?
Okay, so yeah, so this is where, in context to a Pixstore solution, we have three flavors of connectivity. We've got our NFS and our SMB. So there are NAS protocols, and then some what we call the native client, which is sort of going into that low latency entry point into the system. Under the hood, that acronym GPFS comes into play. Now, similar to the ATTO 360 tool, the Pixstore solution, we have an installer, if you will, which enables a Windows or Linux client through a series of sort of controlled steps to attach a workstation into the storage in that kind of high performance path, I guess. And that would be the closest analogy to kind of direct connecting into my fiber fabric, say if I was running a legacy SAN.
All right, we have time for one more. And I'm looking, and I think this one's pretty interesting from both of you, if you could answer it. What are your predictions for the next 5 years for the adoption of NVMe over Fabric compared to the adoption of a SAN infrastructure?
Do you want to go first, Tom?
Sure. Yeah, I mean, I would probably like to light a fire under that adoption for sure. I mean, it's something that we've been pushing for around 4 years now, maybe 5. It has been slower than we'd like, but we're certainly, like, the release of this software, we're trying to make it easier. We're trying to I don't know if I could predict. I would certainly, I think NVMe and being able to bring that over to the Fabric is something that and I hope this presentation would help when you see the speeds that Andrew's team has put together, and when you start thinking about doing things like editing in 8K or 4K and doing color correction over Ethernet, you need things like RDMA to get the job done. So, I think in 5 years from now, I absolutely believe that RDMA is basically going to be in every workflow from a production. Regular IT is absolutely using it right now. It's I'm starting to see more and more tier ones adopt it. Some major tier ones, just recently have introduced support for RDMA. So I think that while I'm not in the prediction game, but I would probably say over the next 5 years, it's going to grow exponentially. I'll put it that way.
Yeah, and I would say, I would say I agree with that. I'm going to quote one of my colleagues, and the real big thing that the last year to 18 months has shown us is that we need to keep creating, and a lot of the time it's going to be on premise, but a lot of the time and more often it's going to be in the cloud. And as far as we're aware, and we work closely with all of the major public cloud companies, is that, putting it bluntly, we're not going to get SAN in the cloud. We're not going to get Fibre Channel. So buying into Ethernet technology now enables us to take advantages of everything that is going to make all of our businesses and our customers' businesses more resilient. And what's been really interesting for us is we're finding that the on-premise footprint is getting smaller when it comes to raw block capacity, but people care about those data rates. So that's why we're pushing on the 100 gig sort of in the real world. But then people are trying to get their data up to the cloud, and we can deliver, because the Pixel solution is software defined, we can deliver comparable performance numbers for parts of the workflow that just blow things away. The commercial models change and the consumption models change, but yeah, we've not seen anyone sort of viably pushing Fibre Channel into that pay-as-you-go, that temporal cloud environment. And I think that is the big thing that is going to continue to evolve. So I feel like Ethernet is the train to be on, quite frankly.
All right, I appreciate that. We had a lot of questions, so thank you for everyone that submitted. I hope I got to most of them. Again, thank you very much to Andrew and Tom for putting this together for us. This again is recorded and will be made available. I'd like to thank everyone, and have a great day. Thank you very much.